this is a worked example on how to find the values of all other trig functions if you're given the value of 1. So we've already looked at ways in which we can kind of devise cosine from a value of sine or sine from a value of cosine. Now we have all these new trig functions, and we can actually kind of expand this process to a whole bunch of trig functions if we just have the value of 1. And so let's again remind ourselves of some of the important equations, and I'll do these along the way because I know there are a lot of them. The big one here is x squared plus y squared equals r squared, and we want to keep in mind what values each function is giving us. So tangent is going to be y over x, and that's kind of resembling the whole idea that tangent is sine over cosine. And so right away, we can actually see that tangent is giving us some potential values, right? So we have tangent equals y over x, and that equals 12 over 5. But we need to be just slightly careful because the final result, 12 over 5, can come from two cases. That can mean y is positive 12, x is positive 5, or y equals negative 12 and x equals negative 5. Either of those cases will give us a positive 12 over 5 because the negatives will cancel. So we want to do a little bit of investigating to find out what actually are the values of x and y. So that's where this line comes in, Q3. And if we remember our quadrants, we have quadrant 1 here, quadrant 2 here, quadrant 3 here, and quadrant 4 here. And in quadrant 3, we are going in the negative x direction and the negative y direction. So to have both a negative x and negative y, that lands us in quadrant 3, and that tells us that this is the case we have. We have a negative y and negative x. And so the actual values of x and y that tangent is going to give us is we have that x equals negative 5 and y equals negative 12. And now I'm realizing I might want to pull up my calculator just to make this next part a little easier. But okay, so now we know the values of x, we know the values of y. We already know the value of tangent, so I am going to erase some of the stuff I have on screen. You can pause the video if you want to keep it, but I think this work is pretty solid. The last thing we want to do is we want to find the value of r, where we want to find that last bit of our equation. So we have negative 5 squared plus negative 12 squared. That equals r squared. And of course, the square root of, well, 5 squared is 25, and 12 squared is 144, and that equals r. So let's see, bad at mental math. That's going to be the square root of 169, and I believe that is equal to 13, but let me just check. Yes, that is 13. So r is 13, and so our r value is 13. And then keep in mind, since r is a radius, distance cannot be negative, so r is always going to be positive. You can kind of just take that for granted. And I'm going to erase this work as well. And whoa, all right, let's go back up here. Okay, now that we have, and will it let me delete this? Nope, okay. Now that we have all of these values, x, y, and r, we can go ahead and fill in the remaining bits of information. And again, I'm not going to write out all of the explicit formulas. If you look on the worksheet where this video comes from, looking at theorem 7.9, I'm just filling in the value of everything, so we can kind of go down the list. We have sine is equal to y over r. It's negative 12 over 13. We have cosine that is equal to x over r, so that's negative 5 over 13. We have tangent, which we already have from the problem, but I will write it out just so it looks nice. We have secant, which equals r over x, and so that's the reciprocal of sine. negative 13 over 5. We have cosecant. That's the reciprocal of cosine. So that'll be negative 13 over... Oh, whoops, did I mess something up? Sorry. The reciprocal of sine is 12. There we go. And then... Oh, no. I'm so sorry. I get them mixed up sometimes. This is 12. It's the reciprocal of sine. Yeah, there we go. Okay. And then cotangent of theta is x over r, and that's the reciprocal of sine. Both will end up being positive. And so those are the 6 values of our trig functions, and that is the solution to our problem. So again, this looks kind of scary because you have to do 5 things at once, but really you're just solving for the remaining values, do a little bit of analysis on whether they're positive or negative, and then find the rest. So that is how you would solve a problem like this.